Hello there! This video is going to show you how to compute a chi-square test for independence using two nominal or ordinal variables in Microsoft Excel. So please follow along with me by going to the linked dataset in the description and go ahead and go to the sample data and copy these two variables, major and first generation college student. This is data looking at a small sample of Statistic students and asking them if they kept the same major that they had when they declared it as a freshman, or if they have changed their major since they were a freshman, and then whether or not they're a first generation college student. So again, you highlight that data, you can go to Edit, Copy, and then make sure you go to the actual version of Microsoft Excel on your computer. Don't do this on the online version. And we will just highlight these two columns and paste our data in. Hooray! Okay, so we need to first get our observed frequencies from our data. So we're going to use a pivot table to do that. So we'll highlight this data. We'll go to Insert, Pivot Table, Existing Worksheet, and then we are going to click on this box where it says Location and click OK. Oh, no, we're not. We're going to click on this box that says Location and actually click Location. So let's go ahead and stick it in right here at D2 and all is well. So you want to be careful that your independent variable or your quasi-independent variable, right, because we didn't manipulate anything here, is the basis of your rows. And then the variable that you think depends on that quasi-independent variable is the basis of your columns. So in this case, we feel like whether or not you're a first generation college student is going to be the quasi-independent variable, or the predictor in this case, of whether or not you stick with the same major or you're sure about your major when you start college. So we're going to click and drag first generation college student over here to the rows, and click and drag major, what we think depends on that, whether or not they kept their major, to columns. And then you can just grab major, put it in values, make sure it says count. If it does not say count, you can click this little arrow, go to value field settings, and select count. All right, I'm going to go ahead and get rid of my blanks here. So goodbye. Now, if you're doing this analysis and you have more than two groups and you want to limit it down to two groups, you can always just get rid of groups by clicking on these options. Okay, so here we go. Now that we have our observed frequencies, so these are our FOs, it's time to get our expected frequencies. And we're going to be using the formula that you saw demonstrated in the chapter right here, which is the frequency for the column, which are these, times the frequency for the row for that specific cell, which are these frequencies, divided by n, which is this grand total sample size right here. So we are going to make some FEs. What I like to do is just copy this table, then just paste the values only. We don't want it to still be a pivot table because we want to play around with it. Now get rid of those frequencies in the middle, but keep your row frequencies, your column frequencies, and your total sample size, because you're going to need that for your formulas, because we're going to be doing this formula right here. All right, so for our non-first gen students who had a different major, we do equals to tell Microsoft or tell Excel we're doing a formula. Click on the frequency for this column. Oh, let's put it in parentheses. Whoop, whoop. Go back. All right, parentheses. Order of operations matters. Click on the frequency for this column. Star. Click on the frequency for this row, right, for this cell. Put it in parentheses. And then divided by sample size. And we're going to do that 3 more times. So here we go. Equals, parenthesis. Click on the frequency column. Multiplication is the star. Now we're in this row, so we're going to click on this frequency row, close it in a parenthesis, divided by that same sample size. Here we go again. We're going to get good at this. Equals, parenthesis. This is now our frequency column, times. This is now our frequency row. Close it in a parenthesis. The little slashy poo to divide by n. Last one. equals parenthesis frequency column times frequency row, close it in a parentheses, slash for division, sample size. So if our null hypothesis was true and there was no relationship between first-gen college student status and keeping the same major, this is roughly what our data would have looked like. Now we can see that our data does not look like this, but we need to do a chi-square test for independence to get our p-value and our overall chi-square value, and then get our effect size to really figure out what's going on here to make sure it's a reliable relationship that we might be seeing. So that's what we're going to do. We're going to get our p-value first. So we go here, p equals, we can just do it right here, equals chi. Look for chi-square test, this option, double click it. Now we're going to highlight the actual range, not the columns and row frequencies, just the FOs right here. Then we're going to put a comma and highlight the expected range, our expected frequencies, close it in a parenthesis and hit enter. Our p-value is right here. So this tells us it's what, a 0.2% chance that the relationship that we see here is due to a fluke. So that tells us we can be really confident that there is a true significant relationship here, which is what you see in the APA style conclusion that we're going to look at in more depth here in a sec. All right, because we actually got a p-value that's not 0.000, we can use the shortcut chi-square formula to get our chi-square test statistic. So I'm going to do it. So equals, and then look for chi-square inv.rt. Double click it. Now we want probability, that's our p-value, comma. Our degrees of freedom in this case is the number of columns minus 1 times the number of rows minus 1. We have 2 columns for our data, don't look at the totals, and 2 rows for our data. 2 minus 1 is 1, and 1 times 1 is 1. So our degrees of freedom is 1. Close it in a parenthesis, enter. This is our chi-square statistic. Now, if our p-value was less than 0.000, right, we would have to do the manual computation, and I will show you how to do that at the end of this video for those of you who may be doing an analysis where your p-value came out to be low, or for those of you who just really like to watch me do some math. But before we get there, I'm going to go ahead and demonstrate how to get Kramer's V, which is our measure of effect size, using this formula right here. So we'll program this formula into Excel. V equals, so equals, warns Excel, we're about to formalize some stuff, and we want to put in SQ and find squirt for square root, and then we are going to click on the chi-square value, and then a little slash for division, and remember the denominator is n minus the degrees of freedom, so I'm going to click on my grand total sample size here. Oh, but before I do, I forgot something. You got to put in that parenthesis so that the subtraction happens first. So, parenthesis, sample size, minus my degrees of freedom is 1. Remember, we have 2 columns, 2 rows, 2 minus 1, 2 minus 1, right? Because the formula for degrees of freedom is columns minus number of columns minus 1 times number of rows minus 1, and 1 times 1 is 1. So, 1. Close it in a parenthesis, equal, oh fine, it's good enough. And there is our measure of effect size with Kramer's V. Okay, so now, and that's a pretty strong effect. So here we go. I'm going to show you, if you really want to, well, hold on, let me actually show you how to do the APA style, and then I'll show you the rough computations if you got P of 0.000. So check out our APA style here. Always announce what analysis you did. Results from a chi-square test for independence show there is a significant, right, because your p-value is less than your alpha. In this case, alpha could be 0.05. It's a really low p-value. There's a significant relationship between first generation status and major certainty among college students at Dr. B's institution. So you mentioned the variables and then the sample we're looking at. Then you want to have chi-square, and then in parentheses your degrees of freedom, which is that 2 minus 1 times 2 minus 1 thing I mentioned earlier, n equals the total sample size, have your actual value for chi-square that you computed, then your actual p-value. You only report p less than 0.001 if your p-value rounded to the hundreds or the thousands place is 0.000, and then report your Kramer's v at the end. Remember to italicize statistical notation and round everything to the hundreds place except for the p-value, which gets rounded to the thousands place. If we have a look at the simple conclusion, we know that there's a relationship, but we want to get more specific about that. We don't just want to say there's a relationship between these things. It's really nice when you only have a 2x2 design because you can really get in there and know exactly what's happening. If you had more levels, you would need to do some post hoc analyses where you create 2x2s and run them over and over again using a Bonferroni correction. But here we go. So let's take a look at this, and we can say those who are not first generation college students tended to have the same major, right? Even more than we would have expected under the null. But among our first gen college students, there was a lot more of them that chose a different major later. They were uncertain, and it's even more than what we would expect if the null was true and there wasn't a relationship. So with that observation, we can go down here and say, first generation college students in Dr. B's statistics class tended to be more uncertain about their major, right? The FOs were higher for uncertain, for changing their major among them, than non-first generation college students. All right, so for my hardcore people, or for those of you who need to do a chi-square test for independence, where the p-value is 0.00, here we go. If you're done and you don't want to see this part, you can just go ahead and leave now. All right, so here we go. So chi-square the hard way, using the manual computations right here in this formula. So here we go. I'm going to keep it in the same format as our data. So equals parentheses, our observed for no different major, minus our expected for no different major. See why it's important to keep these in the same format? It makes it easier to do this. Okay, parentheses, then hold down Shift 6 if you're on a PC, or if you're on a Mac, do whatever it takes to get a caret, 2 for squared, divided by that FE again, equals. Now I'm going to do it here. Equals, parenthesis, observed for no, same major, minus expected for no, same major, close in a parenthesis, happy little caret, and a 2. You can see that right here, right? Okay, then divided by that same expected frequency. 2 more times, here we go, equals, parenthesis, observed frequency for different major, yes, minus the expected frequency for that same group, and then happy little caret, right, close in a parenthesis, caret, and then a little 2 to square it, divided by expected frequency again. So equals, parenthesis, observed for yes, first gen, right, and same major, okay, minus, there's our minus, the expected frequency, close it in a parenthesis, happy little caret, and a 2, then divide by, right, put the little slash there, the expected frequency again. Bam. Now, let's see what happens if we sum them all up. Equals, sum, double click, all you guys, boom, same exact value. The hard way. All right, so I thank you for sticking around for this part, and I hope you enjoyed learning how to do a chi-square test for independence in Microsoft Excel.